Right, g'day mates. Welcome to the EOC review. I'm talking about the quadratic functions document that I gave you in class, mates. If I sound extraordinarily excited, it's because I'm doing this one on the smartboard and Mr. Howell hooked me up with this headset. So right now I'm in my room, like I've got this headset on like I work for NASA. Houston, we have a problem. Houston, we have a problem. Anyways, getting to the point. So we're going to talk in this video about quadratic functions. So standard form of a quadratic function is that you have y equals ax squared plus bx plus c. Remember, it's a quadratic because its highest exponent, the degree of the function, is 2. As you can see there, that 2, highest exponent is 2. A, b, and c are constants. So as we talked about in class, an example of a quadratic is like y equals x squared plus 3x plus 1. Or y, that's a terrible y equals negative 16x squared plus 8x plus 5. Or it could look something like h of t equals negative 16t squared plus 32t plus 4. And you've talked about this in English before. That's called foreshadowing. Oh, don't mean to move that. So here's the situation in example 1. From 4 feet above a swimming pool, Susan throws a ball upward with a velocity of 32 feet per second. The height of the ball t seconds after Susan throws it is given by h of t equals negative 16t squared plus 32t plus 4. Foreshadowing, there's that equation again. We want to find the maximum height reached by the ball and the time this height is reached. So the key here, the key word in this question is the maximum height. Anytime that we're finding maximums right now until you guys get to math 2 or math 3, we're talking about using the calculator. So let's take a look at that. So I need to go to the calculator. I want a graph. And so in F1, I'm going to put the function negative 16. It was t squared. In the calculator, we have to use x. Negative 16x squared plus 32x plus 4. Let me backtrack to make sure that was the right equation. Yes, it is. So make sure you type that in right. Now you hit enter. Bam. I can see this graph. But unfortunately, I can't see the maximum because it goes off the screen. So I need to change my window. Now I'm going to change the window by going to menu, window zoom, window settings. And the issue is my Y max doesn't go high enough. So let me change that to like 40 just to be safe. Okay, so I do that and now I can see the max. Now I can find it. So menu, analyze graph, maximum. I need to set a left bound, so I go somewhere left of the maximum. It doesn't matter how far really. And then the right bound, upper bound, somewhere to the other side of the maximum, and I press enter. So we can see that maximum. What does that mean in context? Well, it's an x value and a y value, x comma y. But in our case, we used h and t, so this is h comma t. The height, sorry, t comma h. The height is 20 at a time of 1 second. So to answer our question, find the maximum height reached by the ball and the time this height is reached. The max height is 20 feet and it was reached at a time of 1 second. So the girl's not throwing the ball very high, so that kind of makes sense. The girl, Susan. So when was the ball the same height as when it was thrown? Let's look at the equation. Remember, it's height based on time. So I need to substitute in for the height this time. So in for the height, I need to put what we're concerned about in this situation, scenario B. So when is the ball the same height as when it was thrown? Well, what height was it thrown from? Let's look. C we set up here is the y-intercept, the initial value. So this ball was thrown from an initial value of 4 feet. So I want to know when did the height become 4 again. So 4 equals negative 16t squared plus 32t plus 4. So what this equation says in English is, at what time, notice the time variables, was the ball at a height of 4 feet? So let's use the graphing calculator to help us find that. You could also use guess and check. So now I want to graph in F2, 4. I need to find the intersections. We already know this one is 0, 4 because that's where she started, but we're concerned about the second one. So menu, analyze graph. I want that intersection this time. I'm going to find the intersection of those two lines. You can only find an intersection when you have two lines because it takes two to tango when it comes to intersections. So it asks for a lower bound. I click somewhere to the left of the intersection. Here's the intersection here, so I hit to the left of it. Now, upper bound, I need to go somewhere to the right of it. So you can see it's like I've drawn crosshairs around that intersection. It's like a game and you're aiming on it. So upper bound, I hit enter, and it tells me the intersection right there. Oh no, is at 2, 4. So again, that means it was at a height of 4 feet, and it was at that height at 2 seconds. So after 2 seconds, the ball came back down to a height of 4 feet. All right, that was a good one. Now let's look at another. A baseball player hits a high pop-up with initial upward velocity of 30 meters per second, 1.4 meters above the ground, where he hit it from. The height of the ball in meters, t seconds after being hit, is modeled by h of t, the height based on the time, equals negative 4.9 t squared plus 30t plus 1.4. The question is, how long will it take for the baseball to hit the ground? So here's home slice, whatever his name is, baseball player. Call him DeMarcus. So DeMarcus hits the ball from a certain height. So here's sketching the graph. He hits it from some height. It goes, comes back down. So the question is, what is the height at this point when it comes back and hits the ground? That's right, the height is 0. So we want to know when is 0 equal to negative 4.9 t squared plus 30t plus 1.4. So let's answer that question first. We could possibly do this one by factoring, but looking at the numbers, it's not going to work out, so we're going to have to use graphing. So let's do that. So I'm going to go to the calculator, f1 of x. I'm going to put negative 4.9 x squared plus 30x plus 1.4. Now you could put f2 of x equals 0 and find the intersection, but the calculator actually already has a special tool for finding the zeros of the function, which is what we call this. So I'm going to show you how that works. So I go to my graph, I go to menu, actions, delete all, because I'm done with that old stuff. Yes, I want to delete everything. So now I'm going to menu, analyze graph. First I have to graph it. What are you doing, Mr. Gordon? Get your head out of the sand. So first I have to graph it. Negative 4.9 x squared, what was it? Plus 30x plus 1.4. Thank you, Jerry. 30x plus 1.4. And I graph that. Okay, so we can see a nice picture of that graph because my window settings were still at the same place they were for the last one, so I don't really need to change anything here because I'm not concerned about the maximum. So there's two places where it hits the ground, here and here. Which one is the only one that really makes sense in the context of this problem? That's right, this one here at a positive time. Negative time makes no sense in this situation. So we can exclude that because the domain we're concerned with is really only positive values of x. So I need to find that intersection point. So I go to menu, analyze graph. I want the 0 this time, not the intersection, because I want to know when the graph hits 0, aka the x-intercept. So lower bound, somewhere to the left of that intersection, that x-intercept, that 0, and then somewhere to the right of that 0. So it tells me that the 0 occurs at 6.17 seconds. So the answer to the question, how long will it take for the ball to hit the ground, is 6.17 seconds. Yay! Okay, now the question is, what time will the ball be 15 meters high? So this is a new equation. 15 goes in for the height equals negative 4.9 t squared plus 30t plus 1.4. How many times do you think the ball was at a height of 15 meters? Imagine someone hitting it up. It goes up and then comes back down. That's right, 2 times. So we're looking for 2 intersections. Just checking my time. Okay, so I graph it. I've already got a graph. Now I need to go into f2 of x, graph 15. Now I need to find both intersections, so menu, analyze graph. Hopefully you're getting the hang of this by now so I can go a bit faster. Intersection. Lower bound. I'm going to find the left one first, the left intersection. So left of that intersection, and then right of it. So that's at 0.493 seconds. Let me write that down. And now the other, menu, analyze graph, intersection. Lower bound there, upper bound there, and that intersection is at 5.63. So the ball was at a height of 15 seconds at was at a height of 15 meters at about zero point 0.5 seconds and about 5.6 seconds, or to be exact, 0.493 seconds, 5.63 seconds. And that makes sense. All right, last and most importantly, this one you should be able to do by hand for the most part. Find the x-intercepts, y-intercepts, and minimum of the quadratic function and use them to help you graph it. So let's start with the x-intercepts. So to find x-intercepts, remember that anywhere along the x-axis here, what's the value of y? No matter what the value of x is along here, that's right, the value of y is always 0. So 0 goes in for y equals x squared plus x minus 12. And I'm just going to write it how we would traditionally with 0 on the right to make Josh Cooley happy. X squared plus x minus 12 equals 0. Now I want to factor the left side of the equation because I'm factoring to solve. Remember when we did this? This is what type of polynomial expression? Quadratic expression specifically? That's right, it's a trinomial, so I need to use the x factor. I'm going to change colors here. So what two things multiply to x squared? Yep, x and x. Multiply to 12 and add to 1. How about negative 12, sorry. How about negative 3 and positive 4? Does that work? Across the diagonals, 4x minus 3x is 1x, so yeah, that does work. So my factorization then is x minus 3 times x plus 4 equals 0. So now I can say x minus 3 equals 0 or x plus 4 equals 0. So x equals 3 or x equals negative 4. So that gives me 2 points that I can plot. X equals 3, x equals negative 1, 2, 3, 4. I'm assuming the scale is by ones on this graph. Now, I'm going to extend the page a little bit. The y-intercept, remember, is clear from the function. Y-intercept is negative 12. So I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the y-intercept is down there somewhere at negative 12. So now I need to know, and it's not perfect, but we're fudging it. I need to know where the minimum is. So I'm going to pause the video, find that in the calculator, and then come back to you guys here. So you can see here I've graphed it, and the minimum is negative 0.5 comma to negative 12.3. So I go back here, negative 0.5 comma negative 12.3 is like right over here. And now I can use that to finish sketching the graph. And that's a horrible sketch, but you get the point. All right, guys, thanks for watching. Have a great day.